All right, welcome back, everyone. This is Junchan, and I'm streaming on Wednesday. Usually I'm not, but I was watching Ed's talk, which I mentioned here, and actually I think I even linked the one on Catch Oblivious data structure that I think he gave at Mozilla, and in it he mentions a few things. And specifically at the very last minute, he sort of towards the end of the talk, like someone asked a question about range queries, and he answers something about like you do a scan and you keep login worth of it in the cache and blah blah, and it gets cut and doesn't finish explaining. But gladly at the end, someone asked him the question again, and he says, "Oh well, what I do for range search is I search the beginning and I search the end, and then I can just do k-way merges and they're fast, so it's no problem." And he says also that this should have the asymptotics of a B tree. So he seems to be giving the recipe to the range query, and I kind of want to try that, except that means I need to sort out my compilation problem. So I just thought I'd get back online and see how far we go with the compilation problem and whether we can implement that range query or not. So how about we try? Okay, let's do Nix develop, and let's try our Cabal bench, I suppose, again. And so vector is 0, 10, 0, 10, 12, 3. So let's try maybe and lower those bounds. Data vector error pin. Oh, right. It could be GHC and GHC prim, because the fact that we can't build vector because it actually seems to conflict with GHC EXTs. So yeah, we should check out maybe if vector, I guess, has GHC dependency pinned. That would be a thing. Let's try package and say okay, fine, vector. And 0, 12, 0, 10, 12, 3, I think is what we got. And 0, 10, 12, 3. 0, 10, 12, 3. And then let's see what so GHC prim is actually not pinned. I wonder what's the evolution speed of that. And let's see, how is vector pin here? Less than 0, 11. But more or equal than 0, 10. So it could be that it's some of the minor changes here have introduced something important. So let's check the change log at 0, 10, 12, 0. See whether there's anything significant there. Building on 7, 9. For 0, 12, 0, 10, 12. Oh. Maybe on 7, 10. Overloaded list, minor bump, overloaded list, fixed compilation. 0, 10, VC array copying bug. Let's see if we can find GHC prim and understand something about how that goes. Right, I think we do have version 040. But let's check, and let's check also the error. Oh, that doesn't come from GHC prims, actually. I think that comes from GHC XTS, doesn't it? Let's see. Do we have access to something like GHC? We do. And GHC EXTS, there's no GHC. So maybe because, well, weirdly enough, we don't have versions older than 8.2.1. Okay, let's search for GHC.exts. Not available. Okay, let's search Google for JCXTS. That's in base. Okay, so do we have, do we need to bound base a bit tighter? Could very well be that we want it to be equal to 4.8. What base do we have? That's going to be a search here, base dash .482 is installed. I want to start at 4.8. So okay, let's see 4.82 how that goes, what we had in JSTX at that time. Okay, I see. Yeah, this is not right. Base and 4820, right? Double check. 4820, yeah. And we want to check out GHT EXTS. And we want to just witness that that it exports a from list. Indeed it does, and that's for overloaded lists, which seem connected to what we were seeing in the changes here. Support overloaded lists. Export M vector constructor. Do we use? I think I remember seeing M vector. Just trying to see. Yeah, and from G, which is data vector generic mutable. I think that's to match vectors, which was already exported. Okay, so that's a different one. But overloaded lists. I think our problem. There is a PVP violation. Oopsie. Oh, because this was probably an important change. So maybe we need to just pin to 0.10.9.2 before there was support for overloaded lists. Let's see whether it's easy to do. I think it won't work if we do it from here, but let's try. So we want to make it strictly less than 0.10. Whoopsie. 9.3. Let's see if we can do that. It seems that you don't want to. 0.10.9.3. Vector 0.12.01 installed. Then it's trying math. It's rejecting something because of conflict with the Victor T Chumbox version, which apparently wants vector 0.12.01. What? Yeah, so there's a whole bunch of things that are unhappy. Then it's trying to continue going back down in vector, including at things that are less than 0.10, like 0.9. Yeah, that would conflict, right? Exactly. So THM box would be the problem. So do we need to Yeah, so I think it's picking up the bound from the library. Rejects bench. Criterion, statistics, math functions, and it rejects math functions because math functions depend on 0, 12, 0. But math function is not directly here. Okay, this was 11. So let's try 0, 10, 10 instead. See whether that works. 0, 10, 11. See if that works. And even 0, 10, 12. That would still be less than 0, 10, 12. And it doesn't work. Okay, let's try with minimize conflict set because it's really hard to read. Still pretty hard to read, but math functions expects vector 0, 12, 0, 1, which is installed. So maybe we just need to re-nix develop here. Although that seems to not rebuild anything. So maybe we need to, I think it's just that package, the way the package is pinned in nix packages that's giving us trouble, I think. So let's try and pick a specific vector implementation from here. Maybe. Let's try it. Vector. And so we were at 0, 10, 12 before. That's what we were getting the errors from. Failed to build vector 0, 10, 12. So let's try vector 0, 10. Well, let's try the one that I was saying. Let's try 0, 10, 9, 2. And we don't need flags. And this is not this. License we don't know, and we're going to need to make this depend on something. I suppose we can go to the nix packages here and go check out whether something else is needed for vector 10, 9, 3, and then there's this one, which is 0, 12. I see. So visibly we need quite a bit more stuff, so let's get that. And make it 0, 10, 9, 2. And then next develop. And call package, yeah, super call package. And super packages dot blah. And here we go. And we get vector 0, 10, 9, 2. And we get the error in the shell. And that's going to rebuild a bunch of stuff. The cabal is not valid. It's trying to get R3 thing. It's this edited cabal file. Maybe we don't want that. Or maybe we don't have R3 as well. to, oh no, it's building. Yeah, but it's going to conflict with some stuff. Okay, let's make sure that this is the correct thing with our revision 3. And then deepsec needs to be less than 1.3, and that might be something we need to check for here. The default one would be which? Not obvious. Not obvious. But we want the one that's less than 1.3. So I suppose we should call 1301 here. Can we do this? And define variable. Yeah, because we need this here, maybe. That's a bit strange, but maybe. 1301. Yeah, no, that looks good. And then primitive. Oh, and then we need array less than 0.5. So maybe that's a little bit too much back in time. So let's revert that, and let's try and see whether going to 0.10 would. We could even go to start with 0.10, 0.10, 11. I think. Go back to from 0.10, 12 to 0.10, 11, 0, and then work our way back. And we need to change the shell, makes sense. Copy. It looks like same, exactly the same dependency trouble right here. Okay, so well, I suppose we then have to carry on in trying to fix things by pinning deepseek, and then having to pin array as a consequence, which is it is what it is. We should have, yeah, we should have 0.52, but I think we needed less than 0.5. So we need to pick a array 0.5, and array is not there. Array, and that would be 0.401. Okay, so let's do that. Let's just call that array and say 0.401. Let's see where that takes us, and same dance with h super here, and packages here and here. And well, revision 1 might be fine. To change the shell. Both for right. Okay, so maybe we change it for each. Seems like it's possible to update a new version by updating a new version of the Cabal file. I didn't know that. array 0401. And now our base is not right. We have base 4.8, I'm pretty sure, with Haskell 710. So yeah, no, that doesn't work. Apparently that just doesn't work. Even by just going down simply one level. So going down more is going to be more troublesome. So the other way around is to try and... No, but specifying, I think, yeah, base it would be 0.82 based on the fact that we use GC 710, and I think that would be it. We are running out of memory here. I think. Yeah, this doesn't say, but I think when we searched, we saw that that was the case. GHC prim 0.4. What's the dealio? Okay, there's something I missed. Let's go, let's revisit our path here. We take vector 0, 10, 11. Tells us he wants an older DeepSeek. And okay, well, and I think what I did was take the maybe I missed a step here. Deep SIG 130. Put it here and here. There might be an intermediary version actually that would work. I picked 130, but maybe there's another one. So let's go check that. Deep sec. Zero 0302 there is, because this one is the one that requires array strictly less than 0.5, and we can't really have that. And we wanted DeepSeek lower than 1.4, and so we could pick 1302, but there's a very little chance that this would actually depend on the right GHC prim, right? In fact, it's already a bit weird. No, maybe it's fine. GHC prim 0.2, that is a bit weird actually. Base let's strictly less than 4.8. Here, also strictly less than 4.8. So how would that work? So maybe vector 1011 really is too old. So maybe that wasn't the right way. And we need to backtrack here. And maybe we need to go a little bit further forward than 1012. That's also possible. That's equal for DeepSeek 140, which is something we kind of want, and primitive 06. That sounds like that's what we want. So let's, which one does it pick? By default, it picks. Well, I think that's the one it picks actually. 0, 10, 12, 3. Damn. Yeah, I'm pretty sure it is. Vector. No, because from the outside 0, 12 is installed. So maybe that plays a role actually. So let's see. Let's say 0, 10, 12, 3. DeepSeek 0, 1, 3. Right, but without DeepSeek 1, 3, we need we can handle the later version. We need to handle the later version, in fact. Missing quick check. 2, 7. Okay, I see. New thing. Let's give it a shot. Quick check. And that's version 2.11.3. We want version 2.7. Fine. We can do that. 2.12 other ones? No. Okay, so or there is 1.2.0, but yeah, that sounds a bit. Well, we want something more recent anyway. So let's start from 2.11.3 and then do 2.7. Well, let's do 2.7 what? We need to find out. Two 7.6. Okay, 9. Oh, I didn't save. Uh-oh. I see. Test framework. Okay. That's failing a lot of things, but hopefully it will work with the where we need test framework version. That's from here. Test framework. Yeah. From vector, right? No, from quick check. Quick check says that it needs test framework, but oh, because I didn't go to 2.7.6 here. Now it doesn't, but it used to. And not directly then. Maybe in its tests. Yes, surely in its tests. Okay. All right, and so let's see. Let's get test framework here. 0.82, and we need strictly less than 0.9. Well, that should be fine. Then what's the dealio? Oh, maybe you needed. Oh well, yeah, maybe you need test Haskell depends. That's what's going on. Okay. And you need it here. All right, look good. Doing manual package resolution is a bit of a thankless thing. It's really I suppose Haskell has gotten way better at maybe because the package maintainer are also doing a better work at setting their version bounds and stuff. And stackage is obviously really useful. And stackage also, I suppose, has a positive attractor effect on the community that is potentially, because I think they email maintainers if something that was building doesn't build anymore. And then stackage is, I think, what's being used by the next packages to define package sets. Yeah. So Ed also says something about his implementation, and since he gave the talk and then did a bunch of changes here, I don't know whether he solved some of those problems or not. But he says, maybe we need to word wrap here. Amortized complexity bound equals to the B tree. Extra log factor slow down on lookups due to the lack of fractional cascading. And traditional data map as a nursery for less than 10. Do 2 lookups. That doesn't really give us a chunk, right? And merge is a low-level function we're not supposed to be using. From list is a constructor. And search is also a low-level thing. But it takes... Is that a... How does it go from keys to integers? The key and chunk, you get a maybe value. wonder what the type of stream is. Can you use that? Or do you just show? Probably not, right? Let's show for chunk and LA, not for map. Chunk KA is chunks of a strict array of K and array of A. And how is the size of the array determined? Oh, this is from data vector array, right? So yeah, these things have, well, they do prefetch, and array is just RAA. And R is what? Data primitive, I think. Hiding array. Hiding the array constructor, but maybe there's an R constructor. There doesn't seem to be. How does this work already? If you have a data family, then using RA just implies that you have some arrayed thing, and then you can. Is that what's going on? So you need an arrayed, and then you use the arrayed A, and you use a vector if it's any A, and then you use this boxing, this properly boxed, unboxed vectors for the rest. This is a box vector for anything else, and then for all of the defined types there, then it's this, such that our in 16, such that array in 16 becomes a vector of in 16. So the first in 16 is used as a key to differentiate the data, the associated data type to the type family. Smartness. So then these arrays get there. And how does this work for, alright, for byte string, you can just use like something that translate your stuff into words of whatever size you want, I think. And you can, and he does pairs. I think for that stuff, I think he's developed like machinery more recently that's much better, I think, but I need to check that out. Okay. Oh, almost. Seems like we only have one error here instead of many, but maybe I'm wrong. Let's check. Exts from list. Exts from list. Yeah, we did have several, right? We have 1, 2, 3 from list 10, and from list in 1476, 1485, and 1476. So we have gained something, maybe. And it was in vector 10, 12, 3, and before it was in, well, a vector 10, 10, 10, 12, 3 as well. Failed to be the junctions. So what's the difference? Well, the difference is that we built this with Cabal build, and now we're building this with Nix develop. That's the difference. So we don't get the whole log. In fact, it's truncated here. So arguably we haven't made progress. We just moved the bug around. Do we want to bump vectors up even more? Originally 0, 10, 11. 0, 11. Let's check again. And I think, yeah. So I suppose we could try these guys. What's the dates? 29? No, that's the revision. Oh, it's not. 0, 10, 12, 2 was uploaded in 2014, 12. Wow. So actually, that might be a better candidate. Let's not go for 0. Zero, 10, 12, 3. Hold on. Is 0, 10, 12, 3 the one that said that it was that they scratched the release because they did the VP an error? No, that was the one before. That was 0, 10, 10. So I suppose we should try maybe primitive 0, 6 is actually what's causing us trouble here. So yeah, let's try to be strictly less than 0, 10, 2, but that won't do much unless we just specify here 0, 12, 2. Let's try this. Okay, and go back to our understanding of arrays. So pairs. Oh well, already failing because you want primitive that's not 0.6, which I think we can do, and I think we've established maybe we would want. So let's try. Okay, primitive. Zero 6 blah 064. Okay, so we do want to go 0510. That sounds nice. So let's do that. next and 0510. Imported for data primitive array. Base is not right. Oh boy. Okay, let's go and check primitive. See if there's something in between that we want. 0510. Yes, there is. Very good. There was 0540. Okay, great. So let's go back to primitive and then grab this, I suppose. Yeah, it looks quite similar. And I think we don't need quick check anymore. I'm just going to comment it out. I hope it's in the cache. I think we say it 540. Let's go check. 540. Yeah. Okay, let's try it. And the usual ish super and pkgs. Yep. Nope. Aha. So that's not gonna work because GCPrim is fixed. So it sounds like we actually need 0.6, huh? There's no way around it. And so does this mean that could be that Ed was using his own version of vector somehow? How would he do that? I mean, that sounds unlikely. How would that work? Let's there's something I haven't done yet, and I want to try now, which is to go into the package and check out the history of the Cabal file. Quick check infrastructure, new project, fetching primitives. Why would this not work? Now I'm also wondering, does it even make sense to change the index state? this really bias anything? Primitive 07. So is there a 06 something version we're missing? 0640. Maybe that's the one we were playing with. Let's try it. Hold on, that's the default one. That the one that says that vector 012, 010, 12, 2 didn't support. Which is, I suppose, why we actually need 010, 3, even though it doesn't work. Hey, Mistran, how's it going? So the data structure we're working on in particular? Well, right now I'm less working on the data structure and more trying to do some archaeology on Ed's packet, Ed's Edworkmet's package structures, which is something that I wanted to dig up after rewatching his talks on Cache Oblivious data structures. Which led to him doing some work also on Succinct and compact data structure later. But I wanted to get a handle on how to use them, and there were a bunch of questions that I had after watching the talk, like how to do things like range queries, for instance. And so I wanted to, when he hinted at some ways to do that, and I wanted to see whether I could actually implement that. What Cache Oblivious and Succinct means. Right. So Cache Oblivious is this concept of a data structure that is actually optimized simultaneously for all of the caches that you have. So it's not perfectly tuned for any one particular cache, but because it's tuned to sort of all of them, it's able to deal well with modern CPU architectures where you have many layers of cache, and that the problem would be that if you tuned your code manually to any particular cache, then you'd end up being suboptimal for all of the other caches. Oh, you do know what they mean. Oh, okay. Sorry. Then you probably know more than I do. You know what I've been doing so far, and I've been also doing last stream when I tried this, was basically struggling to revive something that's 7-8 years ago, and trying to use Nix to get the package set in a state where actually it compiles and it can run benchmarks. Yeah, and the reason and the sort of data structure in particular is a map. So at least that's the one that I'm looking at right now. And that's the model of the Cache Oblivious looker head array, but that's been sort of reworked by Edworkmet with this strange way to both use a kind of a weird numbering system to build structures that can be merged later by having structures at the top that hold small bunch of data, and then each time you have something that will make you need a larger data structure, then creating something which holds two of those plus one with a thunk that is the merge operation of those two that will be evaluated later, which is his attempt to make the Cola looker-ahead array data structure into something that works in a persistent setting. And yeah, as I said, he has lookup, but then I'm like, he describes how to do range queries at the end of a talk that I was just watching, and I thought, okay, I think I understand what he means. Maybe I'd like to implement this range query. He said something like, you look up the beginning, you look up at the end, and then it's really easy to do the aggregation of the chunk between the beginning and the end. It's really fast. I believe him, but I don't think there's code, and I'm curious about whether that can be implemented on the basis of his code. So that's what I'm playing with. You're not an expert in the subject. Okay, cool. Do you use Haskell yourself? Exercise, yeah, it's one of those exercises to the reader. That's right. I'm also trying to evaluate this because he seems to have been sort of aiming at doing something which would be both cache oblivious but also succinct. And there's a bunch of later work that's succinct, but I don't know whether it is cache oblivious. And so I want to see whether it's actually possible to use any of his succinct things. That I suppose also there's something in my mind also about like whether it's possible to implement like more of a tree data structure with fast access using the cache oblivious aspect, because he has a set and a map. I wonder whether you can build a tree, and then it seems like with the succinct data structure, actually a tree is a good fit. And so I want to play with that a bit. All right, cool. Excellent. What do you write usually in your day-to-day work, if I assume that you're a programmer? Yeah, so the quick check dependency was actually needed at this point, but I think maybe it's moot to try and solve it at the next level. I think I can just go back down into my Linux shell and then try and solve it at the Cabal build level here, and maybe play with my index state. C++, all right. Yeah, Edward Met that did this package, definitely been basically envious about the fact that the folks in the C++ ecosystem pay much more attention to this kind of modern CPU architecture optimizations, whereas the Haskell community is a bit, floating in Pure Land, and by doing that, maybe missing some opportunity to make things screaming fast on modern CPU architectures. All right, that's nice. Yeah, that's the advantage of time, indeed. I myself not so young anymore. But I did definitely discovered Haskell on the late, but it's been a bit of a love story since I've started. Since I looked at it the first time and was like, okay, why am I even looking at this? This doesn't make any sense. And then coming back to it, thinking, okay, there's clearly more to it than meet the eyes. I'd like to understand what's up. Okay, so all right, we have a different error now. Okay, WTF. So you're picking primitive 054 here, but that's not going to work. Ugh. The thing is, these days, optimizing for cache is often the highest value in terms of performance. Indeed. Indeed. As well as picking up like succinct data structure are really impressive in their design and their capability to do a lot of algorithms really fast. So both optimizing for modern CPU architectures and picking up like modern data structures is something that's really cool to try and do in a functional programming context. And so this work from 7, 8 years ago, I think it's been picked up a bit in the community, but not in any significant bits or in any significant way. So I'm trying to dust it off and just familiarize myself with it a bit more. Okay, I probably need to just Cabal clean. That's probably one thing, and that means that's gonna spend the world rebuilding the world. I might have changed some other bounds in the Cabal file. Let's yeah, I need to go back to this 11 bound here. Vector 0, 10, 12, 2. Yeah, that's not gonna work. We need to rebuild here. Yeah, 10, 12, 3 has better chances of succeeding. And bumping into the same error after going around this. There's a bit of a dependency hell difficulty, especially with Haskell from back 7-8 years ago. It was actually pretty easy to get into a dependency nightmare, and so these days this is pretty much a solved problem. But yeah, going back in time means going back and finding those old problems where things are really fiddly. Oh well. All right, yeah, we're getting the right errors. So I suppose I could check out data vector and fix those ambiguous occurrences and go for it, because I couldn't find a version that compiles with everything else. So I think that's the way. So let's go find data vector and let's clone it. Okay, that's not what I wanted. Definitely still not what I wanted. Copy pasting in Linux is tough. And what am I doing? Okay. There's a blog post that argues that random memory access is not O1, but O square root of n. Pretty much hits the nail on performance of data structure these days. Huh. I'm not so good on... I've heard of the data structures with square root of n as their asymptotic complexity, and that was kind of a weird thing. But I'm not sure I understand what you mean. Random memory access is not O1, but O square root of n. Is that related to cache utilization? Right, so let's look at the tags. And we want to be around, well, fortunately, doesn't seem to have what we want. Okay, well, how about the releases? We say 0, 10, 12, 3. 0, 10, yeah. Okay. Well, I suppose we go here and then we look at the commits and then we try and find 0, 10. Deepsec 140. So that might be around here actually. I think. Let's look. Let's go to package vector 0, 10, 12, 3 and the change log. Right, I think primitive 06, that would be one of the latest things. At race bound for JC prim and primitives, so that would be around here. So okay, let's check out that commit. Okay. Yeah, okay, copy pasting from the browser does not work. JC 710 primitive 06, I think that's right, and that would be the commit, right? Okay, and so now if I cabal build this, well, you're going to pick up that vector. Rejecting vector 0, 11. Okay, let's go check whether cabal actually says that it's, oh yeah, it says that it's 0, 11. Well, we shall lie. 0, 10, 12, 4. The idea is that every time your dataset grows larger than one level of cache, you take enough slowdown from cache misses if your accesses are random that it's about square root access. Yeah, makes sense. And the square root terms come from the physical limit of how much data you can fit on the plane. Yeah. As the data grow by n square, the distance to the data necessarily goes by n. Right. So the actual physical layout actually matters, right? If we had 3-dimensional memory, then we'd have a different locality factor that would come into play. That's so fun. Access latency necessarily grows by n as well. Yeah. I get it. Thank you. That's quite useful to understand what the thinking is about this. Oh, did we already pass the compilation error? No, 19 of 19 is where ours might show up, maybe. And yeah, they do show up, and it's the same ones. Wonderful, but now we have the code, haha, so we can actually take our destiny into our own hands and say that we can hide some packages from GC XTS. That would be data vector.hs, right? This is yes, and you say exts, and here we go, exts as exts, sure, but hiding from this, please, because this is a little bit ridiculous. And okay, I think we finally, oh no, parser input on as. Okay, I think this is not the syntax. It's not the syntax I'm looking for. As blah hiding. The funny thing is the square root term actually fits empirical observation well from L1 to network access, right? That's really cool. Yeah, that thing for sort of simultaneously optimizing for caches that you don't know the parameters of for cache oblivious data structure is really cool. And do you see in the C++ world that actually this is a very common practice these days for low-level programming, that actually that's one of the first things that you will reach for something that's performance sensitive, like data cache oblivious data structures? And where are we? Failed to build data vector, parse input error on hiding. Okay, so I don't know how to do the proper syntax. I think it might be you have to do it in two different import statements. I think you have to do import blah and then hiding blah, I think. So you do qualify hiding and then as blah, maybe. Then I remove hiding here. And actually it compiles, but it says ambiguous occurrence. So I suppose the other, it says originally defined in GHG-EXTS. I'd say it's imported from data primitive arrays, actually, not directly from. So where is data? Oh, holy moly, that's a transitive dependency. Okay, so I'll fix this differently then. 1766. Yes, they are great. Are there data structures that are hard to represent in a cache oblivious way? Or generally you have pretty much anything you need? 6 from list, G from list. G being data vector generic. Oh, hold on, I'm looking at the wrong place. 388. Right there. You don't know. All right. What kind of projects do you work on? Data.vector.from list. Probably not here. In fact, probably here. And then 389 from list n. Yeah. Okay. Clearly, there would be those. I suppose. And still one more, 508. But we're finally making progress. And that would be this one. And a bit more. Okay, 273. 27. Oh, but in another. Hold on, where am I? Generally, you prefer vector over linked list. Yeah. And you might split your structured data into multiple separate arrays if you need the whole structure array together. Yeah. Think about memory layouts. Yes. That's something that I've been starting to get both from Edward's talks as well as looking a bit at what's happening in the game industry, and things like Unity moving to this idea of like a data-oriented technology stack. Is that how they call it? Which is really catching up with that aspect that memory layout is the main thing that will drive performance. 273 in data vector and oh, that's the export list. You want to know specifically what we're exporting. Huh. Oh, I am a little bit stupid. This is what I should have done. Okay, it's fine. Can still be fixed. and it will be fixed by hiding in the place where it needs to be hidden, which is here, hiding from list, then, and to list. And that should be much better, except without the typo. Basically, for performance, you're trying to optimize your memory layout in such a way that your actual algorithm touches the least number of cache lines, preferably without worrying about the actual size of the cache lines, right? Which is really the essence of cache oblivious design. Yeah. Yeah, it's really interesting, this idea that if you have somewhat symmetrical data structures, then because of, what is it called, like the set associative arrays that are used for low-level caches, that you will end up rewriting always at the same place in the cache, and then just overwriting overwriting what you'd like to keep in the cache to go faster in indexing, going down a data structure. That's quite cool. Okay, what did I do? Let's reset and rebuild. Oh yeah, I did solve the vector error. Finally. Oh boy, that took way too long. Right, but also if you put in a cache line, then ideally you should use the whole cache line for something. Right. Yeah, I was looking at this, like there's like the CPU intrinsics. Like actually in some of the code that I'm trying to build here, there's prefetching code, and I didn't know that, but basically if you take a look at this, like some of these data structures right there, they implement this prefetch R0, 1, 2, 3, and this in the GHC runtime, these are all compiled as either with the LLVM backend or the native GHC backend. They're compiled to x86 CPU intrinsics that translates into loading into specific cache levels, or with what seems to be called like cache locality, hints, with this idea of a non-temporal data, and this idea of optimizing for streaming data, where if you optimize for streaming data, then you try to prefetch everything that is forward ahead of you in the memory space, and try to preload all of that into your caches. Or at the other end of the spectrum, what I understand is that you care about, it's more like LRU, like it's like whatever, you try and look at the data pattern that you've been using and then storing that in cache instead. Putting 64 bytes typically into cache to read a single byte is total waste. Right. Yeah, which leads to structure of arrays, and what is it, arrays of structures of arrays and things like that, like they use in ECS systems in gaming, entity component systems. Okay, where am I now? Fail to build hybrid vectors. Okay, because of, so this error, that seems to be failing to build the junctions, which I don't think we have as an explicit dependency here, do we? Junctions, we don't, but maybe it's a dependency of hybrid vectors. Let's go see what the dependency of hybrid vectors is. Hybrid vectors, and no, that's not it. Your personal experience is that it's hard to get much out of explicit prefetch, as often out of order windows can hide some of the latencies. Oh. And CPUs, I guess, have some heuristics to prefetch straightforward access patterns to make anyway. Right, yes, straightforward for sure. Yeah. So where does the adjunctions stuff come in, and can I pin it to something different? Junctions 421 from lib. Or VDC fallback. Let's see, could it be in vector algorithms? Nope. Or maybe it used to be. Okay, let's reverse dependency search on junctions. Categories, folds, joint, linear. Do we have linear here? No. No. Period, plots, rings. Oh, streams? You have streams? No. Vector sized. It's possible that it may be hybrid vectors. Maybe I went too fast. Machine and can extensions. Use can extensions here? No. Oh, maybe lenses depend on it. Not directly, but let's depend a bit on the world. On the other hand, the best way to kill performance is to play cache ping pong. Right. That's what's happening if you put multiple pieces of mutable data is by different threads into the same cache line. Right. Yeah, I wonder how that applies to GPU programming. Because there is a little bit of caching there, but then each core has locality. Yeah, each core also has like locality issues, but then it's a bit more difficult to reason about this performance aspect, right, in the GPU. So maybe this lens. Junctions. Blah, 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 blah. Hybrid vectors. So maybe it is hybrid vectors after all. Which version would we be using? Since we are between we're less than 1, so it would be oh well, it would be 0 to 2 actually. Is that what we're trying to build? I think it probably. Oh no, we're trying to build 0, 1, 2, 1. I believe there are similar issues, but I do not feel qualified to talk much about GPUs, as I've not done much beyond traditional 3D rendering. Yeah, that's another layer of where the hardware is going. But it seems that in terms of continued chasing for performance, then that massively parallel approaches for some algorithms is the right way to go. And then there's some interesting questions that pop up around like minimizing copying between different parts of your architecture, like from the network card to GPU memory, for instance. Right? How fast can you do that? Maybe even avoiding a round trip to CPU memory. I don't even know if that's possible, but I've been pondering about it. I mean, without specialized hardware, that is. I mean, we are with some of the consumer grade stuff. Okay. What am I looking at? For some reason, I'm compiling 0 to 1, maybe because of prim 0 to, or maybe because of, what is the bounds? This requires 4. And that's it. That's the only bounds that change. So why don't you try with the later version? It's not clear. But or vector 0, 0, 10. This is also vector 0, 10. I'm not really good at debugging these things. So I suppose I could just do the same thing and get the junctions in and fix this. Let's do that. It's probably going to be faster. Yeah, I suppose getting a junctions is probably the right move. Okay, let's do it. Junctions. And the clone gonna work better. And add it here. And let's get some commit that makes sense. Okay, we were failing with 421. I suppose we can just check out v421, and then go to control monad representable state. And either control monad representable state leaf call CC. So that's in the expert list that you're unhappy. 32 it is. So because we should hide control monad identity here, we should be hiding lift call CC prime. You have a question though. When implementing performance data structure in Haskell, how do you use monads to mutate in place, or are they still done immutably? Well, that's one of the beauties in this particular construction, is that they are persistent immutable data structures. So he did move the state of the art forward in there because there was no such cache oblivious data structure working in a persistent setting. And the example is the one where when you're adding to the smaller arrays, and then once in a while building larger arrays, and that makes you amortize with the proper ratios. One problem that can occur in a persistent setting is that one version of the data structure would hold to an array of the size just before the array is going to be expanded. And if someone else is holding on to that same array, or even yours, in the same thread, you also have a copy of that same array before it grows, then you could end up paying the price twice, and that would screw up your asymptotics. And so the way that there's a trick apparently that comes from the Bible of persistent data structure design, that from Chris Okazaki, designing how is it called? Designing Chris Okazaki designing persistent data structure, or well, there's a thesis, purely functional data structure, and then there's a book, purely functional data structure. Yeah. And one of the common tricks is to use laziness to deal with these kind of problems. And specifically here, you see that there are strictness annotation for these two chunks, which represent the chunks that you're currently working on. But here, there's a chunk that is not strict. It's lazy because it's just holding on to a thunk that will be evaluated just when it's needed. And the fact that it's a thunk means that if there are two copies and then one actually makes the array grow and pays for the computation, then that thunk is now evaluated and the other copies will actually not have to pay again for it. And so that was his contribution there to the design of cache oblivious data structure in a Haskell context. Hey, Seydou, how's it going? I like Haskell. Oh yeah, be lazy. Yes, right. That has to be the thing we do. That's good programmers are lazy, no? We try to automate things away as much as we can, so that we can do nothing. Wait, Haskell has if-defs. Yeah, you have C++ style if-defs for things like GHC dependent things, right? Like this language extension only exists for GHC more than 7 or 8, so you can use if-defs for that. Also, like this particular hint to the GHC runtime with the type, the role annotation. That's something that's from GHC 7 or 8. But this code is actually old. I'm doing Haskell archaeology, looking at a repo that hasn't been updated since 7 or 8 years ago, and I'm using the superpowers of Nix to go back in time and try to compile it, and it's hard. But I want to play with it. Good, excellent. Have you played with Haskell at all, Seydou? Okay, let's. Where are we here? Oh, we have another error. I think, is that a... I could not find data vector fusion stream. A member of the hidden package vector blah blah. Perhaps you need to add vector to the build depends in your .kbar file. That's for hybrid vectors. So I'm going to need to import that too. Oh well, this is our life. And state still ambiguous call to call cc, right? Because we also need to hide call cc, but that's not too complicated. And yeah, I think we can deal with the hybrid vector problem as well. Lift call cc. Are you actually building? You're building new stuff, that's for sure. Do I write much C++? None at all. No, but it's a language I really want to learn. I think functional style is the future to some extent. Yeah, I think it is too. It's way more promising than O. Yeah, I've done just a tiny bit of O back in the days. I mean, I've learned C++ and I've learned Java. haven't done much actual paid work in it. C is your favorite language so far? Oh, nice. Yeah, I do think that, Mistran, who's also hanging out in the chat, is also a C++ developer. And what I've heard, and you guys can tell me if that's true or not, is that since templates have become quite a prominent things, and because of the semantics of template, because they need purity, that has attracted a number of C++ programmers to functional programming language, thinking like, why are these constraints there, and why should it improve the world? And then slowly coming to see that there's a whole functional programming world hidden from sight. Generally, is that something that you say has happened? All right. Hybrid vectors. We need to download those. You actually bought a book on compiler design. Oh, not entirely convinced it's so much about purity of templates as such. No. Yeah, just generally trying to improve improve the world, I guess. Improve your code. Find things that are more maintainable, easier to think about, and whatnot. Yeah, templates are very interesting, but I don't think that's true. I think people are just kind of sick of, oh, right. But like the update to the standard has suddenly been moving towards better support for functional concepts. Right. You guys have lambdas, right? I think, Java got lambdas also, right? C++ can only be moved so far. Yeah, but I suppose Rust is doing good work, but yeah, the truth is Haskell is not quite there in terms of being able to really take advantage of some of the low-level stuff around, like new data structure style that take advantage of modern CPU architecture so much. C++ has lambdas, yeah, very useful, yeah. Best thing ever added to C++, yeah. Look at the C++ features, still very disappointing. Nice, terrible introspection. Right. Yeah. Yeah, in other parts of the stream, I'm playing around with the GI suite of bindings from the whole GNOME projects. I think this is all like, and GStreamer. I think this is all C++, right? And I think like this whole GI thing is basically an introspection framework, right, for objects, and it's it looks like quite a bit of overhead conceptually, but I think they get away with not a lot of overhead performance-wise. Yeah, definitely. Yeah, with this, like the plugins descriptions and the ability to dynamically connect to objects and whatnot it's pretty damn good. I'm impressed, and there's bindings for Haskell, so I've been playing with that in some of the other topics I explore in the stream. Okay, so hybrid vectors, and I did not clone those yet. Where am I? Yeah, I'm in the right place. And which version? 0121. Do we have tags for that? 0121. We do. Git checkout 0121, and then let's add this to our Cabal project file. Hybrid vectors, vectors. Okay, and then what were the errors? The errors were, there were some warnings, and then all right, could not find module data vector fusion stream. add the vector to the build depend of the Cabal file. Sure thing, let's do it. So hybrid vectors, Cabal file, and build depends. What do you mean vector is there? Okay, well, try to build it again then. Maybe this is just a weirdness. Reflection is basically the number one thing everyone gives you when you ask them what they think C++ needs to add, right? But coming up with a version that the standard community is happy with proved to be somewhat non-trivial. So that's something that's actively worked on then. Interesting. So you guys still have hopes that it might actually show up, and that would definitely improve the world. Yeah, it's funny. I wonder if it's because that's something, I mean, I suppose it sounds nice. I don't necessarily also see, well, it sounds like you'd have to make some trade-offs performance-wise. No, for C++, because you hate it. You want to make your own language. Yay, once I get money. All right, is that the limiting factor? Start today, man. You don't need the money. You need the energy, and the money will come your way if you design something good. Nah. Right. Yeah. Okay, what's going on there? Compiling data vector. Okay, that's good. Are we going further here? Might be. By the way, you know, what you're seeing here is definitely not representative of the typical Haskell development experience. I mean, sometimes it is, but this whole like dependency issues, that's something that's definitely been so improved in the past 2 years in the Haskell community, maybe a little bit more. It's just because I'm digging up 7 or 8 year old code that I'm struggling right now. Although, to be honest, building is still non-trivial, especially if you have lots of external library bindings and whatnot. So that's why a lot of the community is moving towards Nix. Have you guys tried Nix? You don't have energy. Yeah, well, it's okay. You know, take it easy. It's true that it is a hard moment for the world, so we got to be gentle to ourselves. Example, I'm working on a renderer. I wanted to have different vertex type, for instance, for plane geometry, texture geometry, text, UI, 3D meshes, animated 3D meshes, etc. Not an easy way to just define a POD type and get the information of the members automatically to generate some layer information for OpenGL. Right. Or Vulkan or whatever API. Yeah. The thing is, there's no performance cost necessarily for allowing compile time introspection of things like types. Oh yeah, for things like type, for sure. Which then ideally allow you to build your own runtime reflection with whatever level of performance penalty you're willing to accept. Right. That sounds like the equivalent in the functional world is dependent typing, where you can sort of reason about your type in a much more computational way, which means that you're basically doing almost like stage compilation in some way, where some things in types can actually end up playing a role in values, and all of these layers communicate with each other. I think we're just starting to see things that way, like more like computational fabric, you know, where instead of having I think inside compilers, things are a little bit like that, right? Where like just-in-time compilation, like you interpret first and then you identify a hot path, and then you optimize that particular path. It seems like that's if we have something that can, you know, start slow but then optimize down to the metal, like with really great optimization, then that's the best of kind of all worlds. What's Nix? Nix is a package management system, and this stream is actually done on a computer that uses NixOS, which is the operating system that is built with the Nix philosophy. And the Nix philosophy is basically everything is completely declarative. So all of your system dependencies are in some sense described in a way that you can trust that they're always going to yield the same results. And for complex, you know, multi-language and, you know, hardware driver plus layers of build systems and whatnot, that becomes a really elegant way to tame something that is otherwise really unruly and leads to lots of trouble. And Nix, the package manager, actually works on Linux, but also on Mac OS. And so it can be a replacement for Brew, for instance, like the system dependency manager in Mac OS. Yeah, it's much more principled, and it has a something called a Nix expression language, which is actually a functional programming language in it to describe your package declaratively and package dependencies declaratively. So yeah, it's really good engineering. It's progressing every day. It's pretty good. You can write plain C. In many cases, it's a very good language, but yeah, you don't have the abstractions, right? What the thing that really seduced me in the functional programming world is this idea that at some point you start building abstractions that, even though they might not be the most efficient when it comes to running on actual hardware, they are really good interface for your brain, for the way the programmer thinks. It allows you to think about more complicated programs because the abstractions are better suited. And instead of having to always think about the machine, which might prevent us from being creative and finding elegant shapes to put together, yeah, the functional programming allows you to get abstractions that you get a lot of power from. And I've seen that progressively I get more and more of that. And yeah, understanding monads is a first thing, then understanding applicatives, and understanding functors, and then understanding, you know, how these things are equivalent to loops, how these things are equivalent to more imperative settings, how they can be used to model both stateful things and more environment-y things. And all of that is really useful. As you know, for the first couple of years I was only just reading, but just reading about functional programming was actually helping me be more productive in my other programming languages. How to write assembly, etc. cases in using intrinsics. Yeah, I wish there was something better sometimes, not overly complex language, something that is fast and has some of these nice features, even in terms of optimization. Kind of painful right now. Have you checked out Rust? Lots of attention on the Rust ecosystem, and you know, if you're interested in graphics programming, there's actually quite a lot of interesting stuff going on there, on like graphics engines written in Rust, and yeah, Amethyst, for instance, right? Open source data-driven game engine, and this stuff is fast because Rust, you know, has this something that in Haskell we're starting to have, like a linear type system, something that allows you to keep track of resources, whether you use, how much you use things, that allows to have the compilers to make really radical optimizations to the code. It means that it gets really fast. C++ can do a lot of the C++ templates can do a lot of wonderful things in terms of mapping from high level to low level with little performance costs. Yes. The problem is that the syntax you have to write in order to do interesting C++ syntax over. Yeah. That's some of the folks that I really like to listen to seems to be coming from that point where they were trying to do more and more C++ metaprogramming, and then realized that they were basically, you know, using concepts that actually came from functional programming, and then started looking at the OGs to get more about that and learn more about how to apply those concepts in C++. To have a low-level control, like having actual useful and sane tools like templates. Yeah, in C there's no templates. Yeah, exactly. If you want to do anything like abstract interface many types, you have to use macros. Yeah, that's the thing. It's, you know, it works for smaller projects when you want to really optimize things. But I think if it grows, then actually these mathematical abstractions, they become a real lingua franca. They become a way to communicate between programmers so that they can understand each other's code much faster. And I think it definitely is delivering on this promise, because I think I'm just looking and observing and learning about the concept that 5 years ago I wouldn't even dream of looking at. And, you know, 5 years ago I wasn't reading computer science papers, but now I am. And it's all because of functional programming. Fine. Yes. Thank you for the correction. Yes, macros are, exactly, because macros are not principled, whereas C++ templates are principled. You don't like Rust? Oh, come on! It looks like it's close to what you want. Maybe I mean, I think like the whole borrower thing, it comes with its own complexities. So yeah, Rust is way too far for you. It means lower level than that, where it means like dynamic hardware level optimization with SIMD, OpenMP, etc. built into the language. Yeah, and there's, for that stuff, I guess you have to go towards more experimental languages, and then it's hard to pick the one that are going to be a good future-proof choice. C is good for writing low-level library code, OS, etc. Yeah, C is never gonna go away, right? Rest is way too high level. I don't like the borrow checker. Yeah. I just don't like the semantics too. Well, more power to you. It's good to be to want all the things. All right. So what did I have there? I had a failure to build lens. Oh boy. But also a failure to build hybrid vectors. So where? Vector algorithms. Oh boy, I hate those log messages. They're really not well designed. Yeah, just reset and build again. C++ is also good for writing low-level library and code. Yeah, absolutely. I mean, I never used Rust, by the way. Understand the concept, but if I made a language, I would stick very close to C. That would be most starting point. No point in changing those foundational things. Well, here's a point for changing those foundational things. Most of the programming, like the Turing machine, is based on a machine model. And the fact that it's based on a machine and that we're humans, to me, points at a divide, which means that we have to think more like in the machine world in order to write good code. And that's really what we do, right? The more we understand the low-level architecture of the machines that we're working with, the more optimized code we can write. So, and clearly that's never going to go away. We need to talk machine code to the machine, then that's totally fine. But a good language, whether it stays super close to the hardware or whether it actually lifts in a way that allows you for it to be closer to the way we think rather than the way the machine work. I think that's something that's actually what C is not doing and what C macros are not doing, right? Because they have this step-by-step machine putting, like this thing that Rich Hickey would call place-based programming instead of value-based programming. You need to care about the place where things are rather than care about the values that you're shifting around. So yeah, I mean, I drank the Kool-Aid. I shouldn't try even to convince you about functional programming, but I guess I don't know if you've heard these arguments before. I might be boring you to death. I know that this has happened to me in the past. Declaring variable functions, you don't know. I really like C. I'm fine with C++, like a feature. Arguably, even modern C compiler, the code you write doesn't always have much to do with the code that the compiler actually emits. Absolutely, but they haven't been really designed in that way, right? Whereas functional programming languages have been designed from math, and rather than the Turing machine, from the church encoding, right? From a representation that's equally powerful than Turing machines, but comes from a different angle. It's not a machine tape-based, place-based approach. It's a function-based approach, a mathematics-based approach. Fail to build lens, fail to build hybrid vectors. Hybrid vector. Source data vector generic lens. Is that the things in hybrid vector that's failing to build? source data, it's not. So that seems like that's the lens error. Ah, here, data vector hybrid internal. Okay, good. Data vector hybrid internal. 925. The data vector fusion stream as stream. Member of hidden package vector. Yeah. We said that, and we have changed the cabal file. So, and no, actually we didn't even need to change the cabal file because vectors was already there. So why do you think it's hidden? Building library for hybrid vector 120. Could not. It actually could not find module data vector fusion stream. Right. Was it in vector at this time? Okay, let's check it out. We do have vector here, data vector fusion stream. Ah, right. Oh, that sucks. I think that's going to create other troubles for me later. Data vector fusion stream. Yeah, I remember when I was trying to solve this problem, I ran into this. So I need to compare. Okay, because I think we use data vector fusion stream also in the code of the library we're trying to build right now, which is not the junctions, which is right here. Map, at least in Fusion. This uses monadic as stream. And ephemeral. Monadic as stream. Ah, okay, so maybe I can actually just switch to monadic and maybe it will just work. Let's cross our fingers and give it a shot. Internal and monadic. Go. If you do any kind of optimization, you can see that in GCC, CLang, etc., it will limit different code based on how you write your algorithm, especially if you have big loops, etc. What they don't do is emit your code 1-1 unless you turn off the optimization, of course. But optimization can still have an effect depending on how you write your code, even your expression. Actually, the test when it was working on my math library, everything has an effect. If you're writing something like 3D math library or physics engine, you have to worry about every detail. Exactly right. Also, it's good not to rely on optimization. Yeah. To really worry about these days is not doing anything in code that will make an optimization harder for the compiler. No, not true, man. Hey, say who? I think you're disagreeing on principle. I think you're actually saying the same thing that Maestran is saying, which is basically in order for your code to be fast, you need to be super careful and you need to understand how your compiler works because anything you do can screw up your compiler, which is kind of what Maestran is saying. Work on many software, you have to engineer right and think about what you're actually telling the compiler to do. Exactly. See, that's what I was saying, and that's what Maestran is saying. So we all agree. Kumbaya. Okay, did I fix this? I did not. What was the next error? Cabal build. Could not find module. Okay, data vector mixed. Okay, good. Data vector mixed. That seems like that would be here and in line 162. Yeah, monadic here and oh, monadic has mstream. Oof. Damn. Well, maybe it's been merged and we pretend that everything's gonna work. La 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 la. Okay. My headphone is beeping. I will need to charge it. Yeah, sounds good. Won't be able to hear anything. Yeah, no worries. I'm actually going to, call it a day there because I've been streaming a bit more than 2 hours now. Actually, exactly 2 hours. And I didn't think I was going to stream today. I'm also streaming tomorrow, and I had a full 8-hour working day before that, so that's a lot of programming. I'm totally running out of steam, so I'll pick that up tomorrow. Also, I'm running into this problem that I think I need a clear head with because I might be just making things worse by trying to solve them the way I'm doing it now. Could not find mixed internal. Okay, I still want to try that. Mixed internal. Data fusion stream. Know how to change this. Come on, build. And one of your projects in optimizing compiler backend, and with just about every optimization doing it is simple, proving that it's safe is tricky. Yeah. Like the idea by the way of expressing something mathematically, like someone was showing me about sets in Haskell and how you can do operations on them, like adding them, doing expression on them. Exactly right. That's totally what I mean. Especially if you do things like graphics, like everything is geometry there, and what you'd want is really to have a way to express your geometry in ways that maybe even are resolution independent, and do optimization based on resolution independent, like things like floats and whatnot, like having to deal with that and rounding errors and whatnot. Like these things can be really tricky for a 3D engine, right? I have a friend that writes a Haskell-based 3D printing slicer, and it's the most precise slicer in the world. So you can, and what you gain in a 3D printer by having a mathematically inclined code base is that you save filament because you don't make rounding errors at all. So you're able to completely optimize for your actual pure geometric shapes. And so adding up, you can save a lot of money by doing that. He was showing me how they are infinite. Of infinite resolution, and conceptually, you can do some pretty funky things with large numbers as well. And in Haskell, that's pretty impressive. That's cool. Yeah, definitely check it out. Wondering that when a language starts looking into dynamic SIMD optimization, where you would write a specialized version of function for architecture, then your program will load them dynamically by checking hardware. Well, my friend, you're in luck. This is exactly the type of stuff that the library that I'm the writer of this library, Edward Met. He's a really special mind. He's really one of the people who's leading Haskell forward in terms of that sort of close to the metal. And making it work for high-performance computing applications, and building cache oblivious data structures and Succinct data structure. And he has a talk on doing SIMD and SPMD compilation, and he's wrote some C++ templates for that, and he's also trying to push the boundary to try and do this in Haskell. So I'm just going to put these into the chat, these keywords, and then you can pick whatever you want. But that should be of interest. Yeah, actually, there's something called the Intel SPMD compiler. And there's also the Haskell research compiler written by Intel that tries to do this dynamic optimization for SIMD. So yeah, that stuff is also being explored in the functional programming world. But yeah, that's where it seems like some of the SPMD compiler, there's Intel implicit SPMD program compiler. I think this attempts to do dynamic optimizations for unrolling, being able to parallelize or vectorize instructions, and and then there's I think the Intel Haskell research compiler. I think also trying to do SIMD optimizations, automatic SIMD vectorization for Haskell. So there's yeah, Intel is doing some Haskell work. I am French, yes. Well picked. When I'm tired, I totally have a stronger French accent. No, I don't speak German, but I live in Germany. I live in Berlin. Yeah, unfortunately, that stuff has stalled. It's a bit sad. But already 4 or 5 years ago, they were doing research on that. Ah, toi aussi, ok. Maghrébin, bah si, c'est pareil. Francophone. Yeah, Berlin is beautiful. Ah, so it's not Said Who, it's Said Who, of course. That's a nice little way to present yourself in the English world as well. Yeah. Awesome. All right, my friend Said Who, thanks so much for watching, guys, and hanging out and talking about the future of programming. I'm going to sign off here, so you guys subscribe, and I'll be back tomorrow trying to get this thing to compile, and we can chat again. Thanks a lot, and take care. Bye bye.